Hi folks, we're going to take a look at this example here where we're determining the equation of a polynomial given information about the intercepts, so the zeros and the y-intercept. So let's take a look at what they're telling. So determine the equation of a polynomial that has a 0 of order 1 at x equals -2, 0 of order 3 at x equals -1, and a 0 of order 2 at x equals 1. And they give us the y-intercept of -6. Okay, so let's remember that if, say, -2 is a 0 of a polynomial, then we know that x minus -2 or x plus 2 must be a factor of that polynomial. And similarly for these other ones here. So let's start writing what we know. We know that x plus 2 has to be a factor of this polynomial since -2 is a 0. Okay. Now they also tell us that the 0 is order 1. Okay, because if I had x plus 2 squared or cubed or to the power 4, that would still make x equals -2 a 0 of this polynomial. But they specifically tell us that it's order 1. Okay, if they didn't, then we can choose whatever order we wanted. Okay, let's go on to the next one. So we know that -1 is also a 0, so we have to have a factor of x plus 1. But here they specifically tell us that the order of this 0 must be 3. So that means that that factor has to have an exponent of 3. And then we go to x equals 1, so we must have a factor of x minus 1, and we know that that order needs to be 2. Okay, so if they're specifying the order, we have no choice. We have to go with that. Otherwise, really, it's up to us. Okay, so this function here definitely has, the correct zeros. Okay. Now let's just see what happens here. Let's say I were to expand this out, because I could determine the. I actually don't even need to think about expanding it out. Let's just replace x equals 0 into this equation to see if it gives us a y-intercept of -6. So 0 plus 2 would be. So let's check this one here, y at 0 here. We have 0 plus 2 is just 2, and then 0 plus 1 is 1, cubed is just 1, and then 0 minus 1, so -1 squared, which is again 1. But we see that with this equation, the y-intercept is equal to 2, not -6. Okay, this is where I want us to think that there are other polynomials that would have these exact same zeros. If I were to put a 2 in front of this expression, okay, it would not change the fact that the function has a 0 of -2, 0 of -1 of order 3, and a 0 of 1 of order 2. If I were to put a -12 in front of this expression, it would still have the same zeros. So that's when we realize that any number as a coefficient to these three factors won't change the zeros or their orders. Okay, this is what we call a family of polynomials. This here represents all the possible polynomials with a 0 of order 1 of -2, a 0 of order 3 of -1, and a 0 of order 2 of 1. Okay, so what we have to do now is find the particular a value that satisfies the other condition we need here, namely the y-intercept. Okay, so hopefully this seems familiar, as you probably would have done these types of problems with quadratics. So now what I have to do is just input that extra piece of information, because I've included all the information regarding the zeros. I just have to input my piece of information relating to the y-intercept. So the y-intercept is -6, okay, when x is equal to 0. Okay, and what I have is a nice, easy equation to solve for a. Okay, so let's do that here. -6 equals a times. So we kind of already did this work here. We know this is going to be 2. 1 cubed is 1. -1 squared is also 1. And so here we can solve -6 divided by 2. And so a needs to be equal to -3. Okay, so the function which satisfies all the conditions given is the function -3 times x plus 2 times x plus 1 cubed times x minus 1 squared. Okay, so what we need to get out of this here is the idea that given the zeros and their orders, tells us what binomial factors we need to have in our equation. Okay? But any constant times that product of binomial factors will also have the same zeros. Okay? So, just a little thing I'll mention is they asked for a polynomial that has these zeros. They didn't specifically say it had that these were the only zeros it could have. So I could have added more factors. It still would have satisfied the conditions. But you always want to go with the simplest version if you can. Okay? So what you do, identify the zeros, identify the orders, and input your binomials or the powers of your binomials. And then remember that any constant multiple of this expression will also satisfy those conditions. Okay, that's it for now.